Welcome back, welcome back, welcome back. We've done our first video on linear programming, and so we're going to continue with it. I don't know how many we're going to do now, but let's see how far we can get. Okay. But before we go, thanks for watching. Seen some nice activity on the channel, but we can always do much better. So if you're not yet a subscriber, please smash those buttons. If you're a subscriber, please let them run in the background. It does mean a lot. So press those buttons, let it run, put it on the playlist. There's nice playlists. Let it run. Forget about it. It's cool. It will help a lot. So remember, we're busy with linear programming, and that's where we ended last time. We ended here. Let me just make it a little bit smaller. It's getting a little bit too busy. Okay, so we ended up here. We have our 4 constraints plotted, and we need those 4 constraints in order to generate our feasibility region. Now, feasibility region is important because it's within this feasibility region that our answer lies in terms of our objective function. So our answer to our objective function can be found within this feasibility region. Okay, so that's very important. We need to be able to calculate this feasibility region. Without this feasibility region, we're basically stuffed. Okay, so that's very important. We need to do that. I'm not going to go for how we get to the feasibility region, etc. That's the previous video. Go and have a look at it. It's nicely explained there. Okay, so what we're interested now is these 4 points here. Remember, this is now a triangle. We've got 3 constraints. Therefore, we have a triangle, and we have to calculate each of these areas within the triangle. Okay, we need those sets of coordinates because remember, our feasibility region lies within this, in either one of these 3 points. So we need to calculate the coordinate of each of these positions. Once we've calculated the x and y, we need the coordinate. We're going to put it into our objective function and then see where we minimize our objective function, which combination of x and z, meaning which combination, which location minimizes that z. And the combination that minimizes, that's our objective function. That's our linear optimization. That's where the x and y will minimize our objective function and still satisfy our constraints. So we need to generate the coordinates of each of these points. So the question is, how do we do that? We know that in each these points, these linear functions are equal to one another. So they share the same x and y. So you can see in this point, for example, it's shared if this is unscaled. We don't know. We will find out whether it's unscaled. But let's assume for now it's unscaled. Then we know this is the y coordinate at that point is 8. We don't know what the x coordinate is. I can guess it's 8 up 1 because it can't be more than 2 because 2 is here. That's 2 there. So it looks like it's in the middle. So that may be 1. So the coordinates here could be 8 and 1. Here it is, I don't know what that would be. It's not going to be 3, but the y coordinate is 2. And here, it's most probably the y coordinate is 4, most probably the x coordinate is 5. Point is, we need to generate these curves. We can visually, if we assume that this is unscaled, we can visually determine those coordinates, the x and y's, but rather not. Let's rather be safe and calculate it. As I said, visually it makes sense. So how are we going to calculate these coordinates? How are we going to calculate these coordinates? We're going to calculate the coordinates using this specific algebraic function, matrix algebra. M-mult, matrix multiplication, minimum inverse, etc. So we're going to use this matrix equation. First of all, what we need to do is we need to set up the tables before we can do this. Okay, so we're going to set up for point 1, and point 1 is where constraint 1 is equal to constraint 2. See there, that's point 1. Constraint 1 is equal to constraint 2. Okay? So what is, and there's x values and y values. Okay, so what's the x value for constraint 1? The x value for constraint 1 is 4. The coefficient is 4 and 1. Okay, so let's copy that. Let's copy that. And what is the coefficients for constraint 2? Coefficients for constraint 2 is 2 and 2. 2 and 2. Okay, remember, this is derived from these coefficients, these linear functions. Is 2 and 2. Okay, and what is, it is, this first one is bigger and equal to, that's a direction, and this one is smaller or equal to, and this one is, what is it, 80, 12, and that one is 18. 12, and that one is 18. Okay, so we need to calculate now the x and y. So that's going to be the x value, and that's going to be the y value. So we need to calculate the x and y value. So how do we do that? Let me just quickly do it nicely. Let's merge that. And we're gonna go through that now. So how do we do this? Okay, so I'm gonna highlight these two cells because that's where I want my x value, my y value, meaning I want the coordinates for that point there. Okay, I want the coordinates for that point. So I'm gonna put it in these two cells. So the x value most probably is going to be 1 and the y value is 8. So this must be 1 and 8 if I visually am correct. You see there's the y, this is the x. But anyway, let's calculate it. If I trust it visually, I can just put it this way. So remember, it's matrix, so I must select both cells, it's equal. And then I'm going to put this whole thing in there. So let me just quickly copy it. I'm going to say equals, and then I'm going to put this one in. But now that value there, is these two values. That value there is, that's those values. Oh, come on. Why is it doing this now? Yeah, that, and then this value is, and then we can just, and enter. Okay, I should have seen that's wrong. Let me just redo that. Just make sure everything is set up properly. Let's just make sure everything is set up. So highlight both equals. Okay, put that in. And let me just rather type it out. So it is A31 to, what's it, B32. Okay, so that's that values, and then this is D31 to D32. There we go. So ready, so I'm just going to press shift enter, and voila, there we go. X is 1 and Y is 8. Let me just put that nicely into that, and let's put it, let's just put that one in, that's it, purple. Okay, so this is the important X and Y. Let's make it blue. Let's make it purple. Okay, so now I can enter this into my objective function. And I'm going to say it's equal to Remember, it's 11 times 1 plus 3 times, it's now F31, F32, and press enter, and I get 35. Make it a little bit more colorful. Okay, so there we go. So at this point there, I've got a y value of 8, I've got an x value of 1. If I put x and x1, so it's 11 times 1, it's 11, plus 3 times 8 is 25, that gives me 35. So at this point there, I'm minimizing my objective function to an output of 35. Let's just make that, let's anchor that so that I copy and paste it. Then at least I don't have to hana with it too much. Not, it's that one that I anchor, not the values in the table. Not the values in the table. The x and y values. Oops. Anchor it. Okay, so now I can copy and paste this. So now let's go to our next point. Let's call it point 2. Point 2. At point 2, let's say this is point 2. At point 2, we have constraint 1 is equal to constraint 3. What is constraint 3? X and y. X is 5 and x is 4 and y is 5. So all I'm going to do here is I have to swap that around. So it's 4 and 4. 4 and 4. And that's y is 1 and 5. And 5. Okay, so that's point 1. So it's constraint 1 and constraint 3. So constraint 1 is 4 and 1. As we know, constraint 1 is 4 and 1. Constraint 3 is 4 and 5. 4 and 5. And so at that point, this point here, said we've got 2, just above 2. So x is 2.65, we can see that. And the y is just below that 1.5. And therefore at that point, we have minimization of 33.376. So that's already smaller than that one. That's already smaller than that one. So let's look at the third point. Let's copy and paste it. So this will be point 3. What happens at point 3? Point 3 is constraint 2. Constraint 2 and constraint 3 is equal. So constraint 2 is 2 and 2. Constraint 2 is 2 and 2. And so at constraint 2, we have 114. So we have that point there, it's like 4. No, that doesn't make sense. Constraint 2. So 2 is 2 and 2. So 2 and 2 and 4 and 5. 2 and 2. Oh, I need to change these values. Ah, man. It's 12. It's 0. Constraint 3, that's 0. Sorry. That's 0. And this is 0, and that's 18. Is it 18? So point 3, that one there, have a look. Can't be 45 and 36. 2 and 2. 2 and 2 is 18. 2 and 2 is 18. And 4 and 5 is 0. 4 and 5 is 0. So 4 and 1. Okay, so that works. 4 and 1 and 4 and 5. That gives us 3.37, but minus 3, that again can't work. Instead of minus 5, sorry, it's minus 5. Minus 5. Okay, there we go. And then this one, also minus 5. Sorry, I forgot about a minus. That's not 5, that's minus 5. Okay, see the others? Yep, they're all positive. Okay, so let's have a look now. So point 2 is x is 2. Y is 2, that's fine. And then that's 2.5. That looks fine. So that point there, which is constraint 1 and 3. Constraint 1 and 3, it's 2.5x and 2y. So that's perfect. And then point 3, which is constraint 2 and constraint 3, should be 4y and 5x, 4y and 5x. And there we go. So we're not minimizing at point 3 because there the z value is 67. We're not minimizing at that point because that point our value is 35. So where are we minimizing? We're minimizing at point 2. At point 2, we're minimizing with a value of 33.5. Okay, so at that point we have 2.5x and 2y. So our solution is this point here. Just make sure if we put it in there that we still satisfy these constraints. So both are positive, né? Remember this point there. Let's make it in a yellow. 2.5 and 2. Both are positive. So this identity is sorted. Let's make it yellow. So that's sorted because both of them satisfy. They're bigger than 0 equal. Let's have a look at constraint 2. My x is 2.5, so that's 8. Minus 5 times 2 is 10. So that becomes a minus, which is smaller or equal to 0. So that constraint is satisfied. This constraint, 2 times 2 is 4. And 2 times 4, 2 times 2.5 is 5. Plus 2 times 2 is 4. So that's 9. 5 and 9. So that's smaller or equal to 18. So that constraint is satisfied. And quite a lot. And this constraint must be bigger. So 4 times 2.5 is 10. Plus 1 times 2 is 2. So that gives me 12. So that's under dot equal to 2 or 12. So all 4 constraints are satisfied with this x and y. Okay, so this exercise, x and y, we minimizes our objective function while still satisfying our constraints. So therefore we have a winner. And our winner is that point. There's our winner. See if we have a yellow here. Shape fill, yellow. And shape outline, yellow. And we have a winner. And our winner is that specific point where constraint 3 and constraint 2 meets. That point there, is in our feasibility region, so it meets all our constraints, satisfy all our constraints, and we're minimizing our z. So we've now solved for x and y to minimize our objective function given our constraints. Voila! And there we go. There's our first linear programming example, where we have a set of equations. And given the set of equations, we have an objective function, we have constraints, we have identity, and we can basically model this in Excel using a simple graph, and using our mathematics and specifically matrix algebra, right? Matrix algebra, we can solve then for x and y for each of those corners, and given those x and y's, we can add it back into our objective function, and then we either minimize or max. If it's maximization, we would have gone 0.3. Minimization, we will go 0.2. And there we go. There it is. Done and dusted. Great, ne? Very, very nice. Couple of ins and outs that you have to remember, but we'll get to as we add more or we do more examples, you will see it becomes more and more easier to do. Now, this is a very straightforward example, ne? But it's there to demonstrate the base, how to get started on it. And you understand why we do linear, because then we can fit it on a graph. If it's not linear, it becomes a little bit more complex. Okay. Now, as I said, we can do this whole thing in Solver without having to do all this maths and calculations and all these things. We can do it in Solver, and it will give you this value. It will automatically do all of this and calculate this value for us. Now, as I said, we don't have to do all of these things, but I think it's nice if you can visualize what we're doing, if you can visually see what we're doing, because that makes sense. Then it makes quite a bit of sense, and you can just duplicate it, and you can just replicate it. Okay. So that is the nuts and bolts of linear programming. Now we're gonna, in the next video, we're gonna look at using this exact example and then quickly run it through Solver and see if we can get the same results as what we've done here manually. So that will happen in our next video tutorial. But leading up to that, we need just to make sure that our Solver is installed. So how do we install Solver? How do we make sure it's installed? We're going to go to File. We're going to go to Options. And at in Options, we're going to go into Quick Access, Customize Ribbon, nope, Add-ins, Add-ins, okay. So let's go there again. So we're going to go File. We're going to go Options. We're going to go Add-ins. And with add-ins, you look for Solver. See, there's a Solver. Okay. Now here, don't press OK. Don't press OK. Press Go. And it gives you this. And here you actually add the Solver add-in. Okay. You add the Solver add-in, and then you press OK. Okay. Now, where does you find Solver? You go to Data, and it will sit in there. So there's your Solver. Okay. So again, File, Options, Add-ins, Solver, Go, select, OK. Okay, in that order. Under Data, Solver. So let's have a look and see quickly. So Solver, what is my objective? Okay. So we need to remember each thing is a cell here. So here we need to set our objective, Z, in this case. So in this case, our objective would be Z, but it's going to be the value just below it because it's going to calculate. So it's going to give me that value there. This value, 33, it's going to give me there. Okay. By changing the variables in cell, so that would be X and Y. Anyway, we'll get to that. And here's my constraints. Here's my list of constraints that I'm going to put it there. Okay. Here's my list of constraints. And then I'm going to say simple linear modeling and make unconstrained variables non-negative. You can keep that, leave it, that's up to you. Let's just keep it. So we basically just set up our spreadsheet. Then we select, then we highlight the variables as indicated here, and we press solve. Okay, so it's not going to solve it, so because we don't have anything. No. Okay, so just close it. Okay. No, man. Close. Now it's going to give me all this dramas because delete. Okay. So that's how we're going to use Solver. And within Solver, hopefully we'll get that value. and we'll get that value, and it will also solve to make sure that we are within our constraints. So that's the beauty of the solver function, the solver function within Excel. And that is going to be in our next video tutorial. We're going to do solver. Okay, so with that said, let's, yeah, looks nice, né? Looks fun. As I said, once you get a hang of it, it's actually quite straightforward. We'll do a couple more examples, specifically how did you arrive these ones? How do you derive these ones? We'll get to that. Okay. Let me save. I'm not going to worry about saving here. That's not needed, so let's delete that. Okay. Let's not waste your time. With that said, let me end this video tutorial here, and look forward to the next one. We're going to work on the solver. And thanks again for watching. Appreciate it. And please remember to like, subscribe, share, hit the bells, watch it, run it, let it run for its entire 40 minutes or whatever. Just let it run, please, in the background. It helps a lot. Put those playlists on and let it run. And with that said, I'll see you on the other side.